Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about amines. Their nomenclature, preparations, and properties. So let us start with nomenclature. In common nomenclature, most primary amines are named as alkyl amines. In systematic nomenclature, they are named by adding the suffix amines to the name of chain or ring system to which the NH2 group is attached with emission of the final E. So, methylamine, ethylamine, and propylamine, these are the examples of common name. If you change methenamine, ethylamine to ethenamine, and propylamine to propanamine. Now, friends, you can see butylamine, isobutylamine, and cyclohexylamine. So, butanamine to methyl 1-propanamine and cyclohexylamine. Secondary amine, ethyl-methylamine, here N-methyl ethenamine. Here this is diethylamine or N-ethyl ethenamine. This cyclohexyl amines N-methyl cyclohexanamine. Now tertiary amine, trimethylamine, and IUPAC system N-dimethyl methenamine. Triethylamine, N-diethyl ethenamine. Ethyl methyl propylamine, N-ethyl N-methyl propanamine. So in IUPAC system, the substituents in H2 is called the amino groups. So 2-aminoethanol, you can see, and 3-aminopropanoic acid, like this. So in aryl system or arylamine, this is commonly known as aniline and benzenamine. N-methylaniline, this is the secondary, N-methylbenzenamine, N-N-dimethylanilene or N-N-dimethylbenzenamine, here para-toluidine or 4-methylbenzenamine. Which arylamine are primary amine, secondary amines, tertiary amine? Just to think about it. Now, the important heterocyclic amines all have the common name. This is pyrrole, pyrazole, imidazoles, and indole. All compounds contains NH, here NNH, NNH, NH. So, you know the pyridine, you know the pyridazine, you know pyrimidine. This is the quinoline, this is the isoquinoline, this is piperidine, this is pyrrolidine, this is thiazole, this is pyrene. So numbering start from this nitrogens 1, 2, 3, 4, 5, 6, 7, 8, 9. In the same way, sulfur got one position, here 2 and 3. In piperidine, nitrogen, this is the one position, second and third and fourth, and like this. Now, physical properties and structure of amine. Amines are moderately polar substances. They have boiling point that are higher than those of alkene, but generally lower than those of alcohols of comparable molecular weight. If you look at some examples here, ethylamine boiling point 70 degrees Celsius, hydrogen bonding. Secondary amine 7 degrees Celsius and 56 degrees Celsius, and hydrogen bonding hydrogen. And tertiary amine 2.9 degree, no hydrogen bond. So boiling point is low. Now, structure of amines. You know the nitrogen atom of most amine is like that of the ammonia. It is approximately sp3 hybridized. The three alkyl groups or hydrogen atoms occupy corners of the tetrahedron. The sp3 orbital containing the unshared electron pair is directed towards the other corner. We describe the geometry of amines by the location of the atoms as being trigonal pyramidal. So look at here, these three bonds are different, and this is the position of lone pair, and nitrogen is sp3 hybridized. So if the alkyl group of a tertiary amines are different, the amines will be achiral. There will be a two enantiomeric forms of the tertiary amine. In practice, however, resolution is usually impossible because the enantiomers inverted rapidly. So, if this is R1 and this is R prime, this is R double prime or triple prime, means all these three R is different alkyl groups. So this is showing enantiomers by flipping like this. So interconversion of amine enantiomers. Ammonium salt cannot undergo inversion because they do not have an shared pair. Therefore, those quaternary ammonium salt with 4 different groups are chiral and can be resolved into separate relatively stable enantiomers. You can see the quaternary ammonium salt such as this can be resolved. So in case of quaternary, means you have the 4 alkyl group, nitrogen must have positive charge, and this positive charge must be counterbalanced with the negative ions. So basicity of amines. You know the amine salt. Amines are relatively weak bases. They are stronger bases than water, but are far weaker bases than hydroxide ion, alkoxide ion, and carbon ion. So look at the reactions, which is indicating the basicity nature of amine. RNH2, it take 1 proton, it is forming RNH3 plus. So Kb is equal to concentration of this species and concentration of this species. Here positive charge MSC, and then divided by concentration of this species. So pKb is equal to minus log Kb. So if Kb is increasing, pKb is decreasing and basicity increasing. So aniline, ammonia, methylamine and ethylamine. If you look at the values of pKb, 9.42 for aniline, 4.74 for ammonia, and 3.36 for methylamine, and 3.25 for ethylamine. So explanation is here why this value is greater and this value is lesser. So the gas phase, the basicity of the flowing amines increases with increasing methyl substitutions. Look at here, this methyl group, this methyl group, and this methyl group. Here 2 methyl group, here 1 methyl group, here ammonia. So this is the order. This is not the order of basicity of these amines in aqueous solutions. However, in aqueous solution, the order is different. Here CH3, this one, and this tertiary is position here. Now it changes. It takes 2 positions here in ammonia. The reason for this, the tertiary amine less basic than primary and secondary amines in aqueous solution. However, the electron releasing effect does make the tertiary amine more basic than ammonia. Now, basicity of aryl amine. P-pi conjugation effect, P-pi conjugation effect, no P-pi conjugation effect. Here plus I inductive effect. So pKb value of aniline is greater than this. Now, Iminium salt and Quaternary ammonium salt. When primary, secondary, and tertiary amine act as a basis and react with the acid, they form compound lock, like a compound called Iminium salts. So ethyl ammonium chloride and diethyl ammonium chloride, like this. So when the central nitrogen atom of compound is positively charged but is not attached to a hydrogen atom, the compound is called quaternary ammonium salt. So look at these examples of quaternary ammonium salt. Tetraethyl ammonium bromide, a quaternary ammonium salt. Quaternary ammonium hydroxide. You know the quaternary ammonium hydroxide, however, are a strong bases. As solid or in solution, they consist entirely of quaternary ammonium cation and the hydroxide ion. They are therefore strong bases as strong as sodium or potassium hydroxide. So, amines are resolving agent. You can see the racemic mixture R is acid. So, if you want to separate this with the R amines, it look at RR salt and SR salt. Then you can remove with the help of HCl and water S form separately with the R form. Some biologically important amines, like here you can see adrenaline, amphetamine, noradrenaline, and nicotine. You know the structure of nicotinic acid, pyridoxine, which is vitamin B12, B6, and mescaline, and morphine. You can see the quinine and thiamine chloride. You can also see chlorophenamine, chloradazepine, and 2-phenylethylamine, and histamine. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching. Next video, I will explain about the preparation of amine and properties of amine. Thanks for watching.